Hi everyone. Today I'm going to be creating a multi-layer perceptron for a regression model. And I'm going to be using the iris dataset. The iris dataset is a very famous dataset in the machine learning and data science community. It is typically used for classification problems and for creating classification models, but I had the idea I wanted to test and try to predict, for example, the petal length. So basically the dataset, if you're not familiar with it, contains 5 columns. We have the species column, which is basically the type of the iris. So we have 3 types. We have Syriza, versicolor, and virginica. These are the species of the iris. For the other 4 columns, we have the sepal and the petal width and length. I'm going to be coding this on Kaggle, and if you're not familiar with it, I will go step by step to explain everything in detail. Okay, let's start. Okay, so we're on Kaggle, and we need to add data. I have already added the iris species dataset, so you can just click here to add it. And that's it. Then you would have it like this, and I will start by running this code and basically getting this data set. It would take just a few minutes to run. So okay, now we have the iris CSV file and the iris database SQLites. Okay, so we're gonna start by loading and reading the dataset. We're going to use the read CSV from pandas. This is our data frame. Like I said, we have the ID, we have the sepal length, the sepal width in centimeters, we have the petal length and the petal width in centimeters as well, and the species. If you're interested in the shape of the dataset, we have 6 columns and 150 rows. So this is the data frame .shape, the .shape function. Then I am going to set index ID. I want to change the index because I'm not going to be using the ID column. So I'm just gonna put it as an index column. Now the data frame looks like this. And by the way, guys, you will find this code in the description down below. To create a regression model, we only need numerical columns. This is very important, and in our dataset we have the species column, which is the type of the iris, and this is a categorical column, so we need to change this into a numerical column. And to do this, we're going to be using the one-hot encoding, and we're going to be using the getDummies function in pandas. So here we specify pd .getDummies df species. Then we drop it from our data frame and we join the column that we have created with the one-hot encoding. So we get this data frame that only has numerical values, and this is what we want to create a regression model. Moving on, we have df.describe. This is basically a very typical function in pandas that allows us, I guess, to describe the data frame. And the point of doing this is check for the missing values, and here we have none, so this is good. Moving on, we have data visualization. I think you all are pretty familiar with the cburn library in Python, and we get these beautiful diagrams. Okay, so now we're going to be starting to create the model here. So first of all, we're going to go from data frame to array using the NumPy library. So we're going to be using np.array data frame. So we have an array, and now we're going to specify our x matrix and our y matrix. So I'm going to be predicting the sepal length in centimeters. So okay, y equals this. So basically I am getting the first column, and x would be, well, the remaining columns. So here I'm seeing the shape of y and the shape of x as well. I'm just going to be adding some few variables m and n because x is a matrix now, and to have number of columns and number of rows. For the deep learning model, for the neural network, I'm going to be using Keras and TensorFlow. And I'm going to be creating a sequential model. It is a very typical model. I'm going to be using a lot of dense layers. Dense layers are basically linear layers. I will try to put here a schema of how it goes. So basically the model that I'm creating here is very simple. We have one input layer, one hidden layer, and one output layer. So the input layer, I picked for the parameters 150. The input dimension is 6 because we have 6 columns. And the activation is going to be relu, which is, a very typical activation function for regression. And then we're going to have one hidden layer. For the parameters, I'm also choosing 150 because basically I'm going to have 150 back from the first layer. So I'm going to also have 150. And for the output layer, parameter is 1 because I'm predicting one element for each row. So we have an input layer, a hidden layer, and an output layer. We only have the activation function relu for regression. I'm going to be cleaning up my code because I have added a lot of comments, but they're quite messy, and I have wrote them in French. We'll try to maybe write them in English or remove them all together. So I'm going to be running my code, the model I'm going to be creating it, and we're going to compile the model. So for the compilation, we have the loss function, which is the mean squared error. This is also very typical for a regression model. In the optimizer, it's Adam. The metrics, I'm also going to be using the mean squared error, and then we're going to be fitting the model. I used for the iterations, I have used only 20. I think it's enough for this model. And for iteration, I mean the epoch here. Okay, so after training the model, we're going to be predicting the model, well, making some few predictions. Here, as you may have noticed, I didn't quite divide my dataset into like a training dataset and testing dataset. I just wanted to test how my model would react. I just wanted to try a regression model on the iris dataset and see how it goes. So far, it's going pretty good. So we have the loss, the mean squared error. They decreased, even with only 20 iterations. They have decreased massively, which is really good. So at the end, the loss is 0.11 and the mean squared error is 0.11 as well. So we're going to be predicting the model. We're going to be predicting X. So this is what we have now, and Y is this. Okay, so first prediction is 5.06 and the real value is 5.1. So you can notice that the predictions are really good for this model. The second true value is 4.9 and the prediction is 4.5, etc, etc. I just made some predictions to, test the model and see how it's doing. And I'm going to print this. And as we can see, the 5 first elements and the 3 last elements. For the first one, like I said, 5.06, comparing to the real value, which is 5.1. Second value is 4.52. And the real value is 4.9, etc, etc. We can see that the predictions are really, really good. We should keep in mind that this is basically, we have no training or just in dataset. This is basically, we have shown the model our dataset and we asked the model to predict what the model has already seen. So this is very important and you should be aware of this. I did some plots to try to make some visualization to see how the model is, like to compare X and Y. But yeah, it's quite messy. The visualizations are quite messy, but they look kind of similar. Both are very messy. They're looking quite similar. So this is what we're interested in. So this is, we're plotting the Y and plotting the predictions, and we have this beautiful plot here. What the model predicted is really close to the real data set that we have, which is really good. And that's it, guys. Hope that was useful.